In this video, I will introduce the basics of SPSS. Note that this video is based on version 28. This means that if you use an older or a newer version, things might look a bit different from what is shown in this video. Okay, so once you open SPSS, you might see the following window. Let's close this window. Note that there are two tabs down here. In the Data View tab, we enter our data, whereas in the tab Variable View, we add information about our variables. Suppose that we have the following data that includes the systolic blood pressure of 5 young individuals and 5 middle-aged individuals. The purpose of this study was to see if there is a significant difference in the systolic blood pressure between young and middle-aged individuals. Let's start to enter the data in the Data View tab. However, I will now show the most common mistake beginners do when they enter this kind of data. This is the wrong way to enter the data in SPSS. Don't do this, because you will then not be able to perform the correct statistical test. Here is how you should think when you enter data into SPSS. Think that each row should correspond to only one person. In the first row, we now have values that come from two persons, one young person and one middle-aged person. This means that the first row incorrectly includes data from two different persons. The only case that I can think of when we have two persons on the same row is when we have done a matched case control study where we have matched individuals into pairs. Those kinds of studies are quite rare, which means that we in most cases should have only one person or one item on each row. So, the correct way to enter the data is therefore to put all the values into just one column, so that each row corresponds to the blood pressure for each of the 10 individuals. I will therefore move these 5 values and put them here, and delete this column. Now we go to the tab Variable View to add the information about our blood pressure variable. Let's first give the variable the name blood pressure. The reason why I got this error message is because I tried to use a space in the name. The name you put here should not include any space or strange characters. Let's instead put a simple name here, for example BP for blood pressure. The column type should basically always be set to numeric. I usually never make any changes in this column. This column is mainly used if you have names in the Data View tab, for example the name of each person in the dataset. If we go back to the Variable View tab, we see the type is now set to string, which basically means that the column consists of letters instead of numbers. The value in the column width sets the number of characters that are allowed to be entered. For example, if I try to add a long name here, I cannot do that because I'm currently only allowed to enter 7 letters, including spaces. But if I go back to the Variable View tab and increase the width, I can now enter a longer name here. Anyway, when we do statistics, the names of the persons or the items are usually not that relevant. So for now, we delete this column. If you now go back to the tab Variable View, we can change how many decimal places that should be shown in the Data View tab. It is currently set to 2, which means that we will see 2 decimal places. Let's change it to 1 and note that we now only see 1 decimal. Since we only have whole numbers in our dataset, it makes sense to set this value to 0 because it looks a bit nicer. Note that this does not round the values, it only determines how the numbers are displayed in the Data View tab. Use the number of decimal places that you think look nice. Next, we type the name of the variable that should be displayed in, for example, the tables and plots that we will create later on. Note that you are here allowed to use spaces and special characters in the name. The column values is only used for categorical variables that I will show later on. Since our variable blood pressure is numeric, we do not change anything in this column. Since we do not have any missing data, we leave this column as it is. This number determines the width of the column in the Data View tab. If we increase this value, we see that the column has become a bit wider. Anyway, we can easily change the width of the column like this. If you like, we can center the values in the column of the Data View tab, which looks a bit nicer. The column measure is the most important one, because we must here tell SPSS the scale of our variable. For numerical variables, we set this to scale. The options ordinal and nominal are only used for categorical variables. Since our variable blood pressure is on a numeric scale, we set this column to scale. Let's go back to the Data View tab. So far we have entered the blood pressures of the 10 individuals, but there is still no information that says that the first 5 values belong to the young group and that the last 5 values belong to the middle-aged group. We therefore need to define a second variable that includes this information. Let's call this variable age_group. Now we enter a label for this variable where we can use a space in a name. For categorical variables like age groups, we must define the value for each group. If we press the plus sign, we can now set a value and a label for the first group. And then we use the value 2 for the individuals in the middle-aged group. Next we press OK. If you happen to use an older version of SPSS, the corresponding window will look like this, where you simply enter the value and the label and click Add. Finally, we should tell SPSS that this is a categorical variable. Categorical variables can either be ordinal if we can order the categories in a natural way, or nominal if it is not possible to order the categories. Since categories based on age can be ordered in a natural way, like young, middle-aged and old, we should here select ordinal. We now go back to the Data View tab to enter that the first 5 individuals belong to the young group and that the last 5 individuals belong to the middle-aged group. Remember that we previously coded the young group with a value 1, which means that we fill in the value 1 in the first 5 rows. Note that we can click here to see the values instead of the corresponding labels. Next, we enter a 2 for the 5 individuals in the middle-aged group. Once we have entered the values, it is good to click here, so that we instead can see the labels of the categories. By doing so, you will be able to identify possible mistakes you have made when entering the values. We have now correctly entered all our data. Let's also center the names of this column, so that it looks a bit nicer. We can now do a statistical test. Let's do an unpaired t-test, also known as an independent samples t-test. Since we like to see if there is a significant difference in the mean blood pressure between the 2 groups, we drag and drop the variable blood pressure to the box test variable. Then we put the variable age groups into the box grouping variable. Note that there are 2 question marks here, which means that we are not done yet. We must therefore click Define Groups. Remember that we previously coded the young group with the value 1 and the middle-aged group with a 2. Suppose that we also would have a third group with old individuals. We must then therefore tell SPSS which of the two groups we like to compare. Anyway, since we only have two groups in our example that were coded as 1 and 2, we can leave it as it is and click Continue. Next we click OK. Note that the new window now pops up, which is a window that displays the results. The first table shows some descriptive statistics, where we can see that we have 5 individuals in each group. We see that the 5 young individuals have a lower mean blood pressure compared to the 5 individuals in middle-aged group. This table shows the results of the statistical tests that can answer the question if the difference between the two means is significant or not. These first two columns show the result from the so-called Levene's test, that tests if the two groups have an equal variance. If its p-value is greater than the general significance level of 0.05, we can assume equal variances and focus on the first row that says equal variances assumed, which shows the result from the classical t-test. If the p-value happens to be less than 0.05, we should instead focus on the second row that says equal variances not assumed, which shows the results from the Welch's t-test. Since our p-value from Levene's test is larger than 0.05, we focus only on the first row. This column shows the difference between the two means. If we take 114.4, which is the mean blood pressure of the young group, minus 127.2, the mean blood pressure of the middle-aged group, we get a value of negative 12.8. This shows the p-value from the classical two-sided unpaired t-test. This p-value is less than the general significance level of 0.05, which means that we can conclude that the middle-aged individuals have a significantly higher mean systolic blood pressure compared to the young individuals. This part shows the 95% confidence interval around the mean difference of negative 12.8. I will now show how the numbers would change if we change the order of the two groups. We therefore do an independent samples t-test again. We then click Define and now tell that group 1 should be set to 2, so that the middle-aged individuals are considered as the first group, whereas the young individuals are now considered as the second group when SPSS makes the calculations. Note that the middle-aged group is now in the first row of this table. Swapping the order of the groups will not change the p-values of the statistical tests, but the negative values will now turn positive. For example, if we now compute the difference between the two mean values, we see that the difference is now positive, because 127.2 minus 114.4 is now equal to positive 12.8 instead of negative 12.8. Now, let's make a nice plot. To create, for example, a bar chart, we can go to the chart builder and drag and drop a simple bar to this box. Then we put the blood pressure variable on the y-axis and the age group on the x-axis. To also display error bars, we select this option. I here like to use error bars that should represent one standard deviation, which is the most common type of error bar. Note that this is just a preview plot, so don't worry if it looks a bit strange. Then we click OK and view the bar chart. Note that the label of the y-axis corresponds to the label we have put here, and that the label of the x-axis corresponds to the label we wrote here. This error bar corresponds to one standard deviation from the mean. We can see that the 5 middle-aged individuals have a higher mean systolic blood pressure compared to the 5 young individuals. However, note that there is an error in my SPSS version, because it says that the error bars represent both 95% confidence intervals and standard deviations. This is obviously not correct, because an error bar cannot represent two different things. This should not be here, so remove it before you put the figure into your report. If you right-click on this figure, you can copy or export the figure. If you double-click on this plot, we will open the chart editor, where we can, for example, change the color of the bars. Note that both bars are selected. If you click on just one bar, only that bar becomes active. Then we can select a color. Next, we can activate the other bar and select another color. Once we are done, we close the chart editor. I will now show how to set up a paired study design, where we have, for example, measured the blood pressure of 5 individuals before starting a certain diet, and then measure the blood pressure again of the same 5 individuals after, for example, 4 weeks on the diet. Since we now have a paired study design, we no longer need this categorical variable. Instead, we put the values like this. Note that one row still includes data from just one person, because the blood pressure has been measured before and after the diet on the same person. So again, one row, one person. We then go to the Variable View tab and set appropriate names of the two variables. Note that both variables should be set to scale, because both variables are numeric. Since we now have a paired study design, we can no longer use the chart builder that we used previously to create a bar chart. Instead, we need to go to the Legacy dialogues and select Bar. We here select that we like to show a simple bar chart, and select the option Summaries of Separate Variables. Then we move both variables to the right-hand side. To display also error bars, we click Options and select Display Error Bars, and that we like the error bars to represent one standard deviation. Next, we click Continue and then OK. The two bars now show the mean blood pressure of the 5 individuals before and after they have tried the diet. If you like to change the label on the y-axis, we double-click on the plot to open the chart editor and click on the label. It is a bit tricky, so try a few times. Then we change to an appropriate label. I will now show how to do a paired t-test to see if the difference in the systolic blood pressure before and after the diet is significant or not. Here we simply move the two variables to the right-hand side and click OK. The mean systolic blood pressure before the diet is 114.4, whereas the mean blood pressure after the diet is 127.2. 114.4 minus 127.2 is negative 12.8. The two-sided p-value of the paired t-test is 0.025, which is smaller than the general significance level of 0.05, which means in this case that the systolic blood pressure is significantly larger after the diet. Same as before, we can swap the order of the two variables. where we set variable 1 as the blood pressure after the diet and variable 2 as the blood pressure before the diet. Then we see that the difference is now positive because 127.2 minus 114.4 is equal to positive 12.8. Note that the order of the variables does not affect the values in the table other than that the negative values turn positive. Finally, I will show how you can save your files. To save the file with the results, we click File and then Save As. Note that this type of file ends with .spv. To save our data file, we click on this window and then File and Save As. Note that data files in SPSS end with .sav. Once you have saved the two files, they will look like this. If we open this file, we can see our data, but we can no longer see the results from the statistical test that we made before. If we instead open the SPV file, we can see the results from the statistical test, but we can no longer see the data. I therefore recommend that you first open the data file and then open the output file with the results. We can now see both the data and our previous results. This was the end of this basic introduction to SPSS. Thanks for watching.